morning, everyone. Today we are going to start physics and we are going to study about the first chapter, electricity. In this summer, you are enjoying under fan when at evening you just close the bulb to light to give light from them. You are playing with mobile phones, listening my audio and video. All things is possible only by the term electricity. Think life without electricity in this modern society. Is it possible to survive without electrical energy in world of technology? Since we are science student, so it is necessary to understand the basic concept behind the word electricity. Look, the basic terms from which electricity defined, that is charge. Charge is a very small particles present in an atom. It can be either positive or negative. Negative means electron or positive means proton. A great physicist Coulomb state about charge and their unit. Coulomb is the SI unit of charge, which is represented by capital C. Now let us know about net charge finding. Net charge means total charge. Total charge can be calculated by multiplying number of electrons with amount of charge on one electron. One electron having charge 1.6 into 10 to the power minus 19 Coulomb. So we can say that 1 Coulomb net charge is equivalent to the charge contained in nearly electrons 6 into 10 to the power 18. Now we can calculate by using the formula Q equal to Ne, where Q is the charge, net charge, N number of electrons, and E is the amount of charge on one electron, which is 1.6 into 10 to the power minus 19 Coulomb. As Q equal to Ne, therefore on separating them, N equal to Q by E. We are going to find number of electrons on 1 Coulomb. Hence, Q equal to 1 Coulomb and E equal to 1.6 into 10 to the power minus 19 Coulomb. On solving, we got 6.2 into 10 to the power 18, approx 6 into 10 to the power 80 electrons. So let us come to know next topic about the current. Simply, the rate of flow of net charge is called current. Current is denoted by capital I. So we can write here a small formula I equal to Q by T, where Q is the net charge and T time taken by the flow of charge. As SI unit of current is ampere, which is represented by A, then we can say that Ampere, it means current, equal to charge, it means coulomb, and time in seconds. So we can define 1 ampere by using this formula. Ampere, when 1 coulomb of charge flowing per second, it means 1 ampere equal to 1 coulomb by 1 second, or 1 ampere equal to 1 coulomb per second. In an electric circuit, the electric current flow in the opposite direction of the flow of electron. Electron means negative charge. It flows from the positive terminal of battery or cell to negative terminal. As we looked in electric circuit, we always mentioned that electric current always flow opposite direction to the flow of electron. It means electron always flow from negative to positive terminal. Therefore, current flows from positive to negative terminal. A small quantity of current are expressed in just like milliampere and microampere. 1 milliampere is just equal to 10 to the power minus 3 ampere, or 1 by 1000 ampere. 1 microampere is just equal to 10 to the power minus 6 ampere. Now let us come to know about the device from which current is measured. That instrument is known as ammeter. Ammeter is an instrument which is used to measure the electric current in a circuit. It is always connected in series through the circuit. Ammeter is represented by a symbol in which a circular part A is written and there is two terminals, positive and negative, in electric circuit. Since ammeter has low resistance, that's why it is always connected in series connection with a circuit. One more thing, as we know, ammeter has low resistance, but a term arises here, that is ideal ammeter. Ideal ammeter, we can say that ammeter which has zero resistance or negligible resistance. It means we can say that the ammeter which has zero resistance, we can say that ammeter is an ideal ammeter. Let us come to discuss about electric circuit. Electric circuit is a closed path along which an electric current flows. As in the given circuit diagram, we can see there is a battery of 3 cells connected with ammeter with a bulb and a key. The arrow shows the direction of electric current in the circuit, and ammeter is connected in series. The electron can only flow when there is difference of electric pressure. For example, water flowing through a tube. It is only possible when there is high pressure at one side and low at another side. Then it will move from high pressure to low pressure. Same as it is, electron also flow. In case of electric current, The flow of charge is made possible due to chemical action within a cell that generates the potential difference across the terminals of the cell. In case of electric current, we can say that whenever charge is flow, it is only possible when a chemical action generates in the cell. Let us come to know about the electric potential difference. Potential difference is just defined as the work done in carrying a unit charge from one point to another point between the 2 points in an electric circuit. By the definition, we can say that potential difference equal to work done by net charge, or V equal to W by Q, where V represents potential difference, W work, and Q is the net charge. The SI unit of potential difference is volt and represented by capital V. Now, let us come to know about 1 volt. When 1 joule of work is done to carry 1 coulomb of charge from one point to another of a current carrying conductor, then the potential difference is said to be 1 volt. That is, we can say that as we know that potential difference equal to work done by charge. If we want to find 1 volt, it means 1 volt equal to 1 joule of work by 1 coulomb. After solving what we got, 1 volt equal to 1 joule per coulomb. Voltage or potential difference can be measured by a device or instrument which is known as voltmeter. Voltmeter is an instrument which is used to measure the potential difference and represented by a symbol V with 2 terminals positive and negative in an electric circuit. Voltmeter is always connected and parallel across the points between which the potential difference is to be measured. It is connected parallel connection because it has high resistance. One more thing about the voltmeter. If a voltmeter has infinite resistance, it means too much, very much, then that voltmeter is known as ideal voltmeter. Now let us come to know symbols for some commonly used instruments in electric circuits or diagram. First, cell represented by the terminals positive and negative. Battery, the connection of 2 or more cells. Key, either in a braces or this. Key closed means put the dot or join the end points. Joint wire, just like a T-point, wire with no joining, only cross. Bulb, ammeter and voltmeter. Now, after this, let us come to know about a great physicist, George Simon Ohm. George Simon Ohm found the relationship between the current flowing through a conductor and potential difference V across the terminals of a conductor using this circuit diagram. Let us look this diagram. It starts from the battery. There is 2 terminals, negative and positive, and this is 3-cell battery. Ammeter is connected in series and a resistance connected with parallel connection of voltmeter, and second end a rheostat. Rheostat is a variable resistance is added with a key. After performing this in our labs, we find the amount of potential difference and current at different, and after finding their ratios we just found that all are equals. It means on increasing potential difference or voltage, current also increases, and so that we got a graph which looks like a straight line between the voltage and current. In this circuit diagram, we come across two new symbols, resistance and rheostat. Resistance commonly drawn by this figure and represented by capital R, and rheostat either this or this. This is also a variable resistance. After performing an experiment by the George Simon Ohm, he gave a law which is known as Ohm's law. According to Ohm's law, George Simon Ohm stated that the electric current flowing through a conductor is directly proportional to the potential difference across its ends, provided the temperature remains constant, that is V proportional I. On removing proportional, there is a symbol R comes, where R is the proportionality constant for the given metal at given temperature and is said to be resistance. The graph between V and I is always a straight line. Now let us come to know more about resistance. Resistance is the property of a conductor that opposes the flow of current. It is represented by capital R and their symbol is this. The SI unit of resistance is ohm and represented by a unique symbol this. Now, as we know, V equal to IR, so we can find the value of resistance R equal to V upon I. As we can find the resistance values on dividing the value of voltage and current, providing them. So the unit of resistance is also derived by the voltage and current. It means resistance means ohm is also equal to volt per ampere. So let us come to know about 1 ohm. The resistance of a conductor is said to be 1 ohm when the potential difference across the conductor is 1 volt and the current flowing through it is 1 ampere. That is V equal to IR, hence R equal to V upon I. On putting the value of 1 unit, we got 1 ohm equal to 1 volt per ampere, 1 ampere. Now rheostat, as we know that V equal to IR, hence I equal to V upon R. It shows that current through conductor resistor is inversely proportional to its resistance. So to increase or decrease the current accordingly in this circuit, a component as used is called rheostat. which regulates the current without changing potential difference, and it is represented by RH. Its symbol is either this or this. It is a conductor has less resistance, then more current will flow through it. It means the variable resistance always slightly differ from one point to second in point. Now let us come to know factors on which resistance of a conductor depends. The first, resistance depends on its length, conductor length. Number 2, resistance depends on cross-section area of the conductor, and resistance depends on nature of material. From first and second, R proportional to L and R inversely proportional to 1 by L, 1 by A. On combining both, we got R proportional to L by A. After removing the proportional symbol, we got proportionality constant, which is rho. This proportionality constant is also known as resistivity of the material of conductor. Now come to know more about resistivity. Resistivity means rho is the resistance offered by a wire of unit length and unit cross-section area is called resistivity. Its SI unit is ohm meter. Since R equal to rho into L by A, therefore rho equal to R into A by L. On putting the units of resistance, area and length, we got SI unit of resistivity is ohm meter. For a material, irrespective of length and area, the resistivity is constant. Resistantly of a material vary with temperature. Resistivity of an alloy, homogeneous mixture of metal है ये, is generally higher than of its constituent metals. For example, the alloy of copper and nickel. Alloys have high resistivity and do not oxidize readily at high temperature. For this reason, they are commonly used in electrical heating devices like electrical iron, heater, toaster, etc. For example, tungsten as a filament of electric bulb. After ending these, let us come to know the connection. There is two types of connection, series and parallel. So, one by one, we discussed for resistance. Whenever resistance connected in a series, the maximum effective resistance. Series connection states maximum effective resistance. Let us take three resistance R1, R2 and R3 that are connected in series in a circuit. Like this diagram. It means same current flows through R1, R2 and R3, but there is different potential difference across the three resistance. According to Ohm's law, V equal to IR. The current I flowing through the resistance in series will remain same, whereas the potential difference V across each resistor will be different. Therefore, for the first resistance, we can write V1 equal to IR1, for second V2 equal to IR2, and for third V3 equal to IR3. Therefore, the total potential difference V equal to V1 plus V2 plus V3. On putting the values of V1, V2 and V3 in this equation and taking out common through the given equation I, we got R equal to R1 plus R2 plus R3. This is the effective resistance R1 plus R2 plus R3. Thus, we conclude that effective resistance of the several resistors joined in series is equal to the sum of their individual resistance. Or simply, we can say that in series connection, the sum of arithmetic, generally these are the addition in simple way. Therefore, we can say that for the n resistors, this is the arithmetic sum of all given resistors. The second one is parallel connection. Resistance in parallel. It gives us minimum effective resistance. Let us take three R1, R2 and R3 that are connected in parallel in the electric circuit, like this diagram. In this diagram, we can see that after this point, the current are differ to each R1, R2 and R3. Let current I1 flows through R1, I2 flows through R2 and I3 flows through R3. So, by using Ohm's law, V equal to IR, we can find I equal to V upon R. Now, for each resistors, we can find the amount of current. For first resistance R1, I1 equal to V by R1. For second, I2 equal to V by R2. And for third, I3 equal to V by R3. Now, for total current, I equal to I1 plus I2 plus I3. Substituting the values of I1, I2, I3 and I in this, we got V upon R equal to V by R1 plus V by R2 plus V by R3. On taking V common from right side, we got, and cancelling, we got 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3. It means the effective resistance 1 by Ref equal to 1 by R1 plus 1 by R2 plus 1 by R3. Thus, we conclude that the reciprocal of total effective resistance of the several resistors connected in parallel is equal to the sum of the reciprocal of the individual resistors. In this section, previous two topics, we studied about the series and parallel connection. Now let us come to know disadvantage of series connection on electric circuit. First of all, in series connection, if any of the component fail to work, then the circuit will break and then none of the component will work. Suppose that your house connection is series, just like a fuse. If fuse stopped working, after that rest appliances of your house like bulb, fan, TV stop working, because fuse is always connected in series connection with your electric circuit of your house. Number 2, it is not possible to connect a bulb and a heater in series because they need different values of current to operate properly. Bulb maximum need 100 watt, but heater about minimum 1000 watt. So there is a difference, lots of difference. Hence, to overcome this problem, we generally use parallel circuit. Now let us come on next topic, heating effect of electric current. Battery or a cell is a source of electrical energy. How? Battery or cell, it means chemical reaction in it will produce potential difference at its two terminal, so that electron will come in motion to flow current through resistors. To maintain this current, the source has to keep expending its energy, and then parts of this energy is consumed in useful work like rotating a fan or glowing bulb. Rest of energy of source is converted into heat that raises the temperature of gadget. This is known as heating effect of electric current. This effect is utilized in devices such as electric heater, iron, etc. So, now let us come to know mathematical expression of heating effect of current. Let us suppose that current I is flowing through a resistor of resistance R for time t. The potential difference across the resistance is V. Therefore, as we know, V equal to W by Q, it means work done in moving the charge Q will be W equal to V into Q. Then, as we know that the rate of change of work done is power, then the power equal to W by T. On putting the value of W from previous equation over here, we got P equal to VQ by T. As I equal to Q by T, therefore Q by T replaced by I, hence P equal to VI. Heat energy supplied by the source for time t will be H equal to P into T. Hence, since power equal to energy or work by time, therefore energy equal to power into time. Putting equation in this, we got H or E equal to VIT. As V equal to IR, we also got H equal to I square R into T. This expression is known as Joule's law. The Joule's law stated that heat produced in a resistor is directly proportional to square of the current I. By the expressing equation, we state these statements. Number 2, it is directly proportional to resistance for given current. And number 3, directly proportional to time for which current flows through resistors. After ending of this topic, let us come to know about application of heating effect of electric current. There are lots of application of heating effect of electric current. Number 1, it is used in electric iron, toaster, oven, heater, etc. Number 2, it is also used in bulb to produce light. Filament of bulb is made of strong metal with high melting point such as tungsten. Tungsten's melting point is 3380 degrees Celsius approx. This filament can retain as much of the heat generated as possible to become very hot and emit light. It is also used in the fuse connected in an electric circuit. Fuse, a safety device, protects the circuit and appliances by stopping the flow of high current. The wire of fuse is made up of an alloy of metal, for example, aluminium, copper, iron, lead, etc. The alloy should be of low melting point and high resistivity. Fuse is always connected in series connection. When large current flows through the circuit, the temperature of fuse wire will increase. This melts the fuse wire and break the circuit. Fuses used for domestic purpose are rated as 1 ampere, 2 ampere, 3 ampere, 5 ampere, 10 ampere, etc. for various operations depending upon the power of appliances using. Example, let us consider an appliance electric iron which consume 1 kilowatt electric power at 220 volt. Therefore, power equal to V यानी potential difference into current. Therefore, I equal to P by V. Hence, 1 kilowatt by 220 volt gives us 4.54 ampere. In this case, a 5 ampere fuse is required. Now, let us come to know our next topic, electric power. In case of electricity, it is defined as the rate of change of electrical energy dissipated or consumed in an electrical energy dissipated or consumed in an electric circuit. As we know that P equal to V into I. Therefore, on putting V equal to IR, we got P equal to I square R. Or as we put over here I equal to V upon R, we got P equal to V square by R. P equal to electrical energy by time. The SI unit of electric power is watt. And by this formula or definition of power, we know that power is equal to electrical energy by time. SI unit of energy is joule and time is second. Therefore, 1 watt is just equal to 1 joule per second. Also, we can define 1 watt. The power consumed by a device when 1 ampere of current passes through it at the potential difference of 1 volt. P equal to VI. It means 1 watt equal to 1 volt into 1 ampere. We also state that 1 watt just equal to 1 volt ampere or watt equal to volt ampere. Next, electrical energy. As P equal to power equal to energy by time, therefore energy equal to power into time. E represents electrical energy and T time over here. SI unit of electrical energy is watt second or joule. Watt second by this formula, power SI unit of power is watt and time is second, therefore watt second or joule. There is a commercial unit of electrical energy which is kilowatt hour or 1 unit. As we know that E equal to P into T, therefore E, it means we want to express it in unit or kilowatt hour, therefore E kilowatt hour, 1 kilowatt into hour. 1 kilowatt has 1000 watt and 1 hour has 3600 seconds. On solving this, we got 336 into 10 to the power 5 watt second, or 3.6 into 10 to the power 6 joule, because 1 watt second equal to 1 joule. Therefore, we can say that 1 kilowatt hour equal to 3.6 into 10 to the power 6 joule, or another unit is 1 horsepower equal to 746 watt. After completing this chapter, you must try to answering the following questions. These are carrying 1 marks questions. For example, first question is, define the SI unit of current. Number 2, potential difference. Number 3, resistance. Number 4, electric power. Number 5, electric energy. All are discussed in our episode. What is the conventional direction of flow of current? Question number 3, define the term resistivity. Question number 4, on what factor does the resistance of a conductor depend? 5, how is the voltmeter and ammeter connected in electric circuit? And so on. There are lots of questions for your practice. All of you, please do this yourself first of all. After that, I will discuss these questions answering in next episode. All of you, just listen very carefully that the chapter electricity we have theoretically all studied in this section, and in the next section or episode we will discuss there some important questions and numerical is the main part of this chapter. Okay, so start to solving these questions, which is given in PDF at the last 2 pages. Thank you, all of you. Stay home and save yourself. Thank you.